This is a used engine from a Japanese importer. It's a twin-turbo Aristo engine. It's pretty much the same engine that comes in the Supras, but this one has the variable cam timing on the intake. Put it on our engine stand and immediately started tearing it down. You can see it's a twin-turbo. What we need to do is pull off all the intake manifold, exhaust manifold, and sometimes these things are hard to take off. So what we'll do is we'll spray some penetrating lube on it, and then it makes the bolts a lot easier to come off. You can see the turbocharger. This one's a twin turbo. Once it's all off, we moved it into the engine room, and super dirty engine, but it won't be when we're all finished. Go ahead and put my gloves on, and we'll start disassembling it. This is the water pump pulley. We'll go and knock those off real quick. And we're going to start with basically the outside accessories and then work our way in. So this is the timing belt cover. There's a couple of Allen bolts there. And this one's really deep. Like our socket didn't fit in. So I'm just using an Allen wrench and then a crescent wrench on the Allen wrench. Break that sucker loose and then pull it out. Now we're going to take the coils off. This is kind of a weird setup to where the coil wires sort of cross over and only 3 of the coils have coil wires. The other 3, it's like coil directly on plug. We'll pull those out and set them aside. Now you can see where the spark plugs are. A little bit of water down in there. So I'm going to tip the engine over and let the water come out. And as I tip it over, you can see the water come out. This is a great engine stand because it's easy to flip the engine over by yourself and come back again. The problem is it's a little bit wiggly. So you'll see during the whole disassembly, like the engine kind of moves around a little bit. But that's okay. It's not a big thing. The pulley is a little bit hard to get off. So I tried the electric impact. Doesn't work. Then I tried the air impact. And it doesn't work. So a little trick, a little pro tip here. You can go ahead and put a couple of flywheel bolts in the back of the crankshaft, wedge a pry bar in there. Then you can get on the front with a big breaker bar and put a whole bunch of weight on it. And eventually, once I literally started lifting myself off the ground, I was able to get enough force to break that pulley bolt loose. Once I got the pulley bolt all the way out, the pulley did not want to come off the snout, so I've got this special puller. And you take a couple of bolts, and they go into threaded bungs that are already in the stock pulley. It's already designed for this type of puller. And you go ahead and pull the pulley off safely. Like, it's tempting to want to go put a pry bar behind it, but the problem is you can start cracking stuff with the pry bar, and it's just not the right way to do it. If you've got the puller, then it's magic. So here's a good view of that puller. And it's pretty simple. It's just a beam with a center bolt that pushes and a couple of other bolts that hold onto the pulley. We'll finish pulling off the plastic cover. So before we pull off the plastic covers, we pull off the automatic tensioner for the serpentine belt. And now we're going to pull off the plastic cover, and you can see all of the timing belts. So these are all the valve cover bolts. The valve cover grommets, this thing's so old. I mean, this is a 20-plus-year-old engine. The rubber grommets have hardened into hard plastic, and they're just falling apart. So after a little bit of manipulation, I was able to get those off, and all that stuff will be replaced. So while this is happening, I actually have a little paper list. And I'm writing down all of the gaskets and stuff that we want to order for it. So when we put it back together, we've got fresh gaskets. Once we get the valve cover off, you can see the camshafts. It's 4 valves per cylinder, 6 cylinders. It's a 24-valve engine. I'll go ahead and put that pulley bolt back in. So there's a way now to turn the crankshaft. And we're going to go ahead and turn it to top dead center. So the camshaft lobe pushes directly on these buckets, and the buckets push down on the top of the valve, and the valve spring and everything is inside the bucket. Go ahead and pull off the crank angle sensor. The crank angle sensor is a sensor that tells the computer where the engine is in its rotation. Go ahead and pull the timing belt off. Now the intake cam, this is where the variable cam is. You don't want to pull apart any of the small 10 millimeter head bolts there. You need to go through a specific sequence. First thing is you pull out the variable cam solenoid, then you pull off this bolt, which is the cover, then you can get to the actual cam bolt. Hold the camshaft with a wrench, there's a little hex there actually, and then you can get the cam bolt out. And the whole variable cam gear comes off now. The way this works is the variable cam gear can change its location relative to from the camshaft to the timing belt, and that's how it changes basically the cam timing of the intake. Those are really good for low-end power, but about 4,000, 4,500, it's all the way back to 0 again, and you lose much of the benefit. But for low-end torque, it's quite good. This is where the variable cam gets the oiling from. It's a hard line that comes up from the block up to the cylinder head. Once you get the banjo bolt out, there's a little filter, so you'll set that aside, eventually clean it. And now we'll go ahead and pull the rest of that line off and set that aside. You can tell that this was sort of maybe retrofitted after the original engines were designed, instead of something more elegant like the oiling going through the block and into the head internally, which is what all the modern engines do. Next is break all of the cam bolts loose. And you got to be careful here because you got to make sure that you're at top dead center and that you move from the outside in. Because if you aren't on top dead center and you unbolt the cam gears in the wrong sequence, the springs are trying to push the cam basically out of the head, and you can end up breaking a camshaft. So it's really important to go top dead center and then make sure that you remove the cam caps from the outside in. And normally the cam will sort of pop up a little bit from the spring pressure on the lobes and then make those not so hard to get off. Go ahead and set those aside. And I put them all in order, but on there's actually a little markings that show you intake, exhaust side, and then numbered from 1 through 7. The number 1 cylinder always starts on the front of the engine. The front of the engine is where the timing belt and pulley are. So what I like to do is number all of the buckets where they came from, because the valve clearance, which they call the valve lash, is set with these little shims that are on top of the buckets. Each one might have a slightly different shim on it. So if you ever put it back together, you want to make sure that they go back in the same place. So I'll use a little magnet to pop these suckers out. And now you can see where the spring retainer is and the top of the valve. I'll go ahead and use the magnet and pull the rest of them out. One of the downsides of the bucket type lifter is you can't put really big camshafts in it because the lobe will be so big that it'll run off the side of the bucket. But they are quite reliable that there's just not a lot of moving parts compared to like a rocker arm setup. Now it's actually time to pull the cylinder head off. So we're going to get down into where the cylinder head bolts are, and they're down sort of buried in there, and they actually take what they call a spline drive. So it's a 12mm spline drive, and they're torqued pretty high. So I'll go ahead and use the breaker bar. You start from the outside in and start by loosening it a quarter turn. Once all the bolts are loose, for speed's sake, go ahead and put the spline drive on an impact and just zip all those suckers out. And then I'll again grab that same magnet, pull the bolts and all of the washers out. I like to set them aside and count them and make sure that I've got all of them out. Finally, the head's off and you can see the head gasket and a 20-plus-year-old engine. That's not so bad. The head gasket seemed like it was sealing up well. It looks like we're starting with a good engine, even though it's quite dirty. There's a couple of features here that really make the 2JZ amazing in what it does, which is such a strong engine. Number one, it's a cast iron block, and number two, it's a closed block, which means it doesn't have like these giant water ports around each one of the cylinders, and it makes the cylinders really strong. So huge boost, and they can just take tons of power. Another thing that makes the 2J really good is the multi-layer steel head gasket. These are really good gaskets from the factory. It uses 3 layers of steel, and they're embossed with different features to help seal the cylinders. And on the bottom of the cylinder head, you can actually see where all of the extra pressure is around each one of the cylinders, and that helps the head gasket from not blowing. Now that we tip the head up, you can see the exhaust and the intake valves, and the hole in the middle is where the spark plug goes. So we'll go back to the front of the engine. We'll remember the timing belt tensioner. Then we'll take off the water pump. There's a little O-ring back there that we got to get. And there's a couple of studs that stick out here. This one is external Torx, and we've got special sockets for those. Both of these are knock sensors, so it's a dual knock sensor engine. And what the knock sensor does is it's like a little microphone, and it listens for like the ping or the detonation, and it sends a little signal back to the ECU, and the ECU can say, oh, I'm having some pinging or detonation, and it'll start retarding the timing and making tuning changes depending on what the knock sensor is hearing and how it's tuned. We'll pop off the oil pan. You know, I hate popping these things off. You got to do a pry bar. If anybody's got a more elegant solution for this, please leave a comment below. It always sucks pulling these things off because you can dent the metal pan and always a little bit scared that you might nick the aluminum girdle side. Another pro tip here, don't flip over the engine all the way until you pop the pan off. The pan is holding a little bit of oil. When you pull the pan off upside down, all that oil goes into the bottom of the pistons and stuff, and it makes it much messier when you go to pull it apart. So what I like to do is pull the pan off with the engine like kind of tilted like a 45-degree angle, and then once that's off, then flip it all the way over and start taking the rest of the underside off. This is the oil strainer or the oil pickup. So this round piece with the little hole in it, the screen, and these 3 bolts is where the oils get sucked up from the pan into the oil pump. And then we've got the oil baffle like splash screen. So that comes off with just a couple of bolts. And then now we'll pull the oil level sensor off. So if you ever have a car that has a little light that comes on and says, hey, your oil level's low, this is an example of what that sensor is. It's a little float. And what happens is it floats on the oil, but when the oil's level's too low, it doesn't float anymore. And then that little float goes down, hits a little sensor and sends a signal back to the car and says, hey, your oil level's too low, throw the light on. So the bolts are actually pretty tight on this whole girdle. This is another thing that makes the 2JZ a really good engine. This whole girdle ties the whole bottom of the block together, and it actually adds more rigidity to the block. Once we get that girdle off, you can finally see the crankshaft, the rods, and all the main caps. So now we've got the timing belt pulley to pull off. Again, you're tempted to put some pry bars or screwdrivers behind there. Try to resist the temptation and don't do that because there's a pickup wheel back there, and if you bend it, then you can start having issues with the crank trigger. So this whole unit is the oil pump. It sucks in oil from the pan and then pushes out those side holes and into these holes here where the O-rings are. Another pro tip, I actually pulled off the bolts for the rear main before I put the engine on the engine stand because it's really hard to get to those bolts. So I pulled off those bolts before I put on the engine stand. So once I got to that point, then I was able to just pry off the rear main seal. Before I pull the pistons out, I want to use a little bit of Scotch-Brite and take off some of that carbon deposits because those carbon deposits will stop the piston or make it much harder for the piston to exit the bore and can also mess up the rings if you ever want to reuse it or reassemble the engine. So another pro tip here. So I'll just unscrew the rod bolts like halfway and then knock them with a dead blow. And what that'll do is get the cap off of the rod. Sometimes it's really hard to get the cap off the rod, and that's just a little trick to do that. Make sure you've got your hand underneath, and I'll go ahead and push the piston out the bottom. You can see here a little bit of wear on the top. That's pretty normal wear. Same with the side skirts of the piston. That's all pretty normal wear, and you can see a lot of carbon deposits. This is normal for a 20-year-old engine. This thing probably has 80 or 100,000 miles on it. So what I like to do is before I take any of the main caps off, is I'll spin the crank and see how well it spins. And it'll give a little bit of an indication of if the block is twisted or anything, and if you need to do an align hone. So I'm going to go through the same strategy as taking the head bolts off. I'll loosen them all a quarter of a turn, and then take them the rest of the way out. And here's another pro tip. I'll put the bolts back in just sort of halfway, and wiggle the main cap a little bit to get them off. Sometimes the main caps are wedged into the block, so they're hard to get off. And you can see the bearings are quite nice in this. Same thing with all of the bearing journals on the crankshaft. And these two JZs have a super buff forged crankshaft, really wide bearings, and a lot of thrust bearing as well. And that all makes it really stout. I mean, it's pretty common that guys are running, 700 or 800 horsepower with just stock engines. Here you can see the piston squirters. They're actually just bolted in. So I'll go ahead and unscrew all of those and set those aside. Another thing to notice in these two JZ blocks is all of the webbing. That's like all of basically the reinforcement and the ribbing that's in the bottom part of the block. And that's another thing that helps these really handle horsepower and really be a rigid block. So thanks for joining me on the disassembly. You can see all the parts here on the table. It's pretty exciting. We're going to continue and build this into a 700 or 800 horsepower setup. So if you're interested in that, go ahead and subscribe, and you'll get notified when we come up with these new videos during the build process. Thanks for watching.